which means that typically there are, um, uh, you know, sorry, one second. Okay, typically there are two factors for which you're measuring five. Factor analysis is also known in machine learning as dimensionality reduction technique. Now, what is dimension? I think as mentioned about last year, you guys are aware of it. Features, features, variables, vectors. They're all similar kind of stuff, which means net rows in an Excel sheet. If you have to very simplify to the bottommost level. So the rows that you see in Excel sheet is nothing but variables, okay, or dimensions. Dimensionality reduction, reducing from 5 to 2, that is dimensionality reduction. That reduces the data and several other things happens, okay. One more thing I would like to to have your attention towards. Have you heard about multicollinearity? Uh, Sachin, Subrat, I'm sure you would have, right? Yes. So I don't have to explain that as well. You must have heard about it. So if you actually what happens in multicollinearity is as follows. Typically, if you have these two variables, okay, obviously, y is always a dependent variable, x is independent variable. Okay. Now you're using x as one this is x1 for the sake of discussion. This is x2. Okay. Y remains same, right? So I'm just kind of for the sake of explanation, I'm using two different graphs. Now there are two x1, the way it changes, I'm talking about the correlation, right? So the graph is like this. And on the same lines, the graph is like this over here as well. I'm talking about this is x2 versus y1. Now both of them almost like overlapping. The correlation is about 0.92 or 0.93 because you can see almost the same. Now you definitely know for sure that R square is all about how close the data points are to the trend line or to the line of best fit as we call it. Okay. Now both these guys come together, and if you move this line over here, all of them are moving together, and that does nothing but that inflates R square artificially. Okay, that is multicollinearity, which means that if you have two variables, x1 and x2, having a very high correlations among themselves, right? If you do regression, y of course is a continuous variable. Okay, so your dependent variable is continuous variable. The technique that you use, machine learning technique that you use is regression. If you're using regression with these two variables, R square is inflated. If R square is inflated, your results are going to be wrong, and that is the reason that you need to either drop. So there are three ways that you can do it, or three or four. One is you straight away drop the variable, right? Like for example, in HR analytics, if you have experience and age, drop either huge correlation, almost one, because as the age increases, experience will also increase. But then there will be some Charlies who would have had gaps. एक साल का gap होगा, किसी का 1.5 साल का gap होगा in experience. Age में तो gap होता नहीं. So in that case, possibly age may, so it might be 0.98, 97, 92, but no, in of data frame, you cannot take age and experience together, right? Just in case you have taken, right? So one way is to drop. Second thing is, I'm not sure if you have heard of a regression called elastic net, right? Actually, lasso and reach. So you can use lasso and reach and allow assign penalty to one of the variables. That is another one. And the third is use dimensionality reduction, which is what we're going to do today. Okay. So once you understand, I'll come back to this little later. Okay. I'm taking one more case here called customer satisfaction. Now this is basically typically a customer who is B2B, यानी कि HRIS ERP vendor. Okay. B2B, your customer size is less, 100, 200 tak jata hai, not more than that. Maybe it can go into thousands as well. I'm not saying no, but typically at a smaller level, B2B people keep it little less to be in control. In fact, it's also there that 20% of the customers generally fetch about 80% or 70% of the revenue, which is all bad, but still it happens in most of the B2B kind of stuff. If you're doing a kind of survey of a customer satisfaction, now over here, B2B. So please don't analyze these words. Okay, we are just looking at the example, and this is not HR analytics. So obviously, you can just forget the words which are there. Now, if you're doing, what shall I say? If you're doing going to do, a factor analysis of this. Okay, so let's do that. So first of all, you can either use a 7-point scale or a 5-point scale, right? Over here, and price is prohibitive. So one being agree and 7 being disagree or whatever. I mean, you can have whichever way that you want to have. That doesn't matter. So there are 12 questions which are asked, and what you get is something like this, which is basically nothing but intercorrelation. because the basis of factor analysis is intercorrelation. Okay, I'm going a little fast. You tell me, stop me wherever you feel like that there is a issue over here. Okay, once you find the intercorrelation, generally, guys, generally, just your state. These are the variables. Okay, or statements, whatever you can call it. Generally, statements are columns and observations are rows. Okay, generally. But I'm just for the sake of showing, I'm here because I'm showing this here because just you can kind of say that okay, this is 7, this is 8, and this is 6. Otherwise, you have to basically row to column to rows. Okay. So if these are the data sets, and you can have n number of observations here, find the correlation, and you'll get something like this. Okay. I'm not putting the value here because I've not done the case completely, but you may end up with something like this. Okay. Now, what is this? A quick question. This is called factor loadings. Okay. I'm sure in learning factor in learning factor analysis, you would have heard this. This is also called, oh sorry, this is also called lambda. Oh God, this is horrible. This is horrible. Okay, it is also called lambda. Okay. Oh God, sorry. My bad. Okay. Anyway, I don't have to write lambda here, but yeah, this is also called lambda. Uh, do you have any idea? I'm asking to all three, four of you that where does this particular thing come in? Any Sachin Subramaniam, Subrat, have you ever given your thought to this? 49. This is factor loading. Okay. Since you have had some idea about it, I'm just asking. I'll come to that. I'll tell you what the lambda comes from. But how the lambda after factor loading comes from where? That is a crux. So have you learned that by any chance? Any one of you quickly can answer. Yes, no, maybe. Subrat, Sachin? No. Super. So I'll tell you now. Sachin says no. Subrat, how about you? The degree to which variation is captured. Not really, Subrat. Okay, fair enough. So if you understand this now, you'll understand factor analysis very well. And the second is this most confusion is about eigenvalue and eigenvectors. I'm not going to take, but eigenvalue. So we'll discuss that also. Don't worry. I'll make it so simple for you that you will never ever understand. Never ever forget that in your life. Anyway, let me first tell you. So okay, this is prices, and if you don't understand, I'll repeat it. Don't worry. As it is, I've delayed it, so I can further delay it, but I'll make sure that you understand this forever. Because factor analysis is not your profession. Once you understand, it should go into a head forever. Nobody should ever teach you that. So price is prohibitive, overall implementation cost. Okay, these are, to begin with, just assume. I'll come to what is lambda or what is this loading, factor loading is all about. आपको समझाऊंगा मैं. फिलहाल जैसे मगअप करते हैं ना, रटते हैं ना, वैसे रट लो for the next 10 minutes. So suppose this is very high factor loading, right? So these three variables have very high factor loading on PC1, which is the first factor which has emerged. In the first example, there were two factors emerging, like customer alignment and likelihood of return. Okay, here it is PC1. PC stands for principal component. Factor analysis is also known as principal component method. थोड़ा variation है. So we have three factors which have emerged: PC1, PC2, PC3, and the factor loading on this, and this, so far as PC1 is concerned, is very high, which means that they are measuring same thing, guys. Which means they're measuring same thing. Any one of you, Sachin, Subrat, can you tell me what is common in this three? Very simple. Quickly, what is common in this three? What do you see common in this three? Because now we have to name the factor. PC1 nahi chalega na, we have to name the factor. Anyone? Subrat, Subramanian, Sachin, what is common? What is common in item number 1 or variable number 1, variable number 2, and I think variable number 7? What is common? If you read as a domain expert, what is the common there? The common thing there is cost. Am I right? Okay, in these three. So no wonder that they are having similar kind of, they're having, high factor loadings of PC1. Okay, which means that if you go back to the previous example, atom number 1, 2, and 7 are moving together. Okay, थोड़ा बहुत ऊपर नीचे होता है, but they will move together. Come to PC2. PC2 में क्या है? Atom number 2, common between what, sir? Subrat, the statements, not between, amongst. Price is prohibitive is one statement which has got high factor loading here. Overall implementation cost, which has got also high factor loading here, and the product benefits do not don't outweigh the cost. All the three have high factor loading on PC3, which means if you have a parallel with the first example which I gave, all first, second, and seventh are moving together, which means there's something common in that. That's why they're moving together. The respondents are giving similar responses to all the three. That's why they're moving together, right? So that is common. Got it? Subrat, have you understood? And that's why I'm calling it cost, because all three of PC1 can be called as cost because they're cost related items. All three of them, if you read the statement, uska crux cost hai. And also they're moving together. Subrat, have I explained this to you? Yes, so common between the statements, yeah, common amongst the statements. Okay. The same next thing, Subrat, is PC2. So PC2 may 0.38, 0.38, and 0.58 almost moving together. Same question. Now, Subrat, can I ask you this? What is the common amongst overall implementation cost? IT department cannot support your product and we don't have sufficient technical resources. What is the common here? Okay, I'm talking about item number 2, item number 9 and 10. Okay, the common thing there is possibly somebody's answered resources for implementation. Towards say actually, yeah, but it is more to do with technical. Right? It is IT. Implementation is all about IT, right? So it is IT. Okay, and third is all about organization. Okay, so if you reorganize this and if you do this, look at this. These three factors, I've reorganized this. Okay, and IT resources, correct. So if you look at it, these three are common where you have cost. Okay, these three are common where you have IT, which is what you have said, and this is common where you have organization, strategy, organization, whatever. And these items are actually not explaining any variation, which is what your earlier question answer was. Okay, that's why I'm knocking it off. Okay. So the question that I asked you about lambda is the 68 क्यों आते हैं 43 क्यों नहीं? That was a question. Okay, and why it has come like that? That's why the variation in a way was right so far as contribution is concerned, but definitely why 68 and why 49? Why not 49? That is the question that I asked, and how does it, how do you calculate that? Okay. So that's how factor loadings are there, and that's how you do. So you actually drop this. These items are, you don't have to drop it; they automatically drop. Okay. So cost, IT, and organizations are the ones which are most important factors, and then you can relate that to customer satisfaction. How to relate that? We are going to do a similar case in employee satisfaction or job satisfaction. So you'll understand how to relate it. Fair. Let's move further. Okay. And now I'm going to ask about. So we last time Subrat, you told me, right? Subrat and Sachin, we did big five, na ocean. We, in the sense, you all have done it, right? I'm sorry, I'm little forgetting now because 1 week there's so many things happen. So you have done big five, right? One second. Yes, super, super, super. So, Abhi, let's go to Big Five also. But before that, quickly, and I don't have to, I'm going to skip these slides because you are aware of it. It helps in data reduction, underlying factor, all those things you would have learned it. So I'm not going to get into that. Factor analysis is useful to me. Data, yeah, this is also you know about it. So I'm going to be focusing on this two now. So first, let me go to test development. So here you have ocean. Okay, you have O, you have C, you have E, A, and N. Okay, so you have ocean here. Now, Subrat, Sachin, Subramanian. Now there is a point where I have, you will understand what is that, lambda coming from. So, Subrat, now you'll know that your answer was partially correct, right? When you said variation, but that's not only variation, that is error variation. So I'll explain that. You have written it over here, but I'll explain that to you. So item number 1 measures extroversion. 2, 3, 4, 5, 6, 7, all of them are measuring extroversion. 7 से लेके 11 तक are measuring conscientiousness and so on and so forth. Now, if I ask you, does item number 1 100% is measuring extroversion? And the answer is no, not at all. Because we are in, what shall I call it? It's very descriptive science in the sense that, you don't know exactly what is being, measured. Okay. Yes, majority of it is measured in, is extroversion. For example, it may measure, say, 70% extroversion. Okay. The statement I'm talking about. If you make the first statement, and I'll explain that to you in a moment. Next slide, I'll explain. So extroversion possibly, sometimes people call it extroversion, some people call it extraversion also. The spelling and pronunciations are like, they go hand in hand. So maybe it measures 70 or maybe 50% extroversion measure करता है. The rest 50% it might be measuring something else. So in that case, 50% is error variance. Okay, in this case, it might be about 40%. Other case might be 60% or whatever. So they're all error variances attached with all statements. All statements. 100% तो नहीं होता है कभी. ये भी नहीं. If it is 100% will happen possibly in your secondary data. Okay, but उसमें वेरिएशन नहीं आएगा, बट कोरिलेशन वुड बी वेरी है. फॉर एग्जांपल आलू के प्राइसेस, टमाटर के, आई एम यू डूइंग इकोनॉमिक्स and doing a principal component analysis, then of course, yeah, you do have secondary data there, but the area variation could be less. Loadings would be definitely strong in economics. In psychology, in sociology, anthropology, political science, for humanities, behavioral sciences, error variances are very high. Okay, and I'll explain that also in a moment from now. So now let's look at the one factor model. Okay, and I'll tell you one factor model, where does it come from? I am saying that, okay, I'm going to run a one factor model. This is my call. So guys, instead of reading is sociable, read I am sociable. So if the statement is I am sociable, okay, the other statement is I'm optimistic about the future. Third is I'm hungry for knowledge, and fourth is I'm happy to try out new things. Okay, so it says I am sociable. It is measuring extraversion. Yes, yes, I'm sociable. It is being social, right? So extroverted people are more social. But is it measuring 100% extraversion? May not be necessarily. Okay, so possibly it is measuring. Oh, sorry. This is, I don't know. This is like I don't know. You guys face the same problem when you make presentation by using PowerPoint, but somehow it when you mark by a pen, it goes all over the place. Okay, so 64 has come from why? Because it is measuring to the extent of 36% or 0.36. Baki 64 is error variation, because it is varying the error. The error is so much that it is like varying so much. Okay, that is the error. Okay, I am optimistic about the future. Yeah, possibly 49% measuring extroversion, rest 51% is something else. Okay, we don't know what is that. ठीक है. I am hungry for knowledge. Hunger for knowledge and extroversion से कोई लेना देना है नहीं. So यहाँ पे the error variance is 0.98, which is 98%. Only 2% it is measuring. हाँ, ये 2% measure करता होगा extroversion, but 98% something else, we don't know what is that. And over here it is 4%. Okay, sorry. How do you get it? So we can say that error variance is 64. कहाँ पर 64 की बात कर रहे हैं? Yeah, first one is 64. Correct. Correct. First one is 64. 64%. Correct. Yeah, exactly. 64% only. Because I'm coming to, when I'll explain that, I'll tell you what it is. So 64%, 51%, 98%, 96%. Now you have such a huge error variance in third and the fourth factor. Okay. So what I'm going to do is I'm going to introduce a two-factor model, because I feel that two-factor model can do a justice here, because there are other two are actually very high error variation. So I introduce a two-factor model. Okay, I will do this in R after a while. That I'll introduce 6-factor, 7-factor also when we'll do it in R. Don't worry, and we'll see what kind of results we get. The moment I have entered this, wow, look at this. Okay, you have got another factor, hungry for knowledge, and this means the statement explains only 36% extroversion. Which one are you talking about? Which one? I'm not sure what you're talking about. 36% though. The first statement, of course, yeah. It is measuring only 36. But let me tell you one thing. In psychology, 36% is not bad. It is not good, definitely for sure, but acceptable. Okay. So this is 36%. This is 49%. Okay. This is 2 and this is 4. Okay. So anyway, anything above 35 is acceptable. Majority chunk jata hai na. So Subrat, that is acceptable. It's the biggest measurement. The next would be maybe 15, 16, 2, 4, 5, whatever hoga. Okay. So now here you see, wow. So I'm hungry for knowledge and I'm happy to learn new things. They're actually measuring openness as per the definition. So your error variation is 0.51 and 0.36. So there's a huge movement from 98 to 58 and 96 to 36. Okay, which is fantastic. So we will go with the two-factor model here. Okay, good. Now, if this much you have understood, then my question to you is, where you give these exams, right? The exams that you have are what do you say? NMAT, CAT, GRE and all that kind of stuff. उसमें एक relation क्या कहते हैं उसको? Sequence and series, I guess. I'm not sure. Series. For example, uh, how these guys are related with each other. 64 and 60, 51 and 70, 98 and 50. Can you quick guess? It is difficult. It is difficult. Okay, there is a relationship, and that's how we calculate lambda. Okay, and the relationship is as follows. Okay, if you so you have 0.6, right? 0.60, a square of 0.60, okay, plus your error variation, which is 0.64, is equal to 1. And when you said percentage, that's precisely I wanted to tell you. So 6 are 36, 0.36, okay, plus 0.64 is 1. 7 sevens are 49. So 0.49 plus 51 is 1. Okay, so that's how lambda is calculated. Now you go back and you will wonder, ये lambda कहाँ से आ गया? वहाँ से आ गया. Correct? So the lambda is calculated from error variation. Okay, largely errors. Have you understood now, Subrat, Sachin, Subramaniam? Now you know where. And don't worry, even if you've not understood, doesn't matter. We will calculate the lambda in the case that we're going to do, and we will see that sum of what is one exactly. Subrat, sum of again. I'll repeat. I'll just could you please explain? Of course, yes, Subrat. No worries. Why, please, yeah, tell me. I'll do it. My job is to make you all understand. Uh, a square of this plus error variation, which is 0.61. So 60 ka square is 36, 0.36. 0.36 plus 0.64 is equal to 1. Uh, a square of 0.70 is 49 plus 0.51 is equal to 1. So lambda ka square, or you can say the other way around also, square root. So square root of 0.64 plus 0.60 is 1. So that's what, I mean, whichever way you can look at it. Okay. So this is, have you understood now, Subrat? A square of lambda plus error variation is 1. Is it okay? Okay, super. So that's how lambda is calculated. Okay. Sure. And now you know exactly. So lambda is basically loading, factor loading. It is very important to understand. Okay. If you have understood this, I'll move to the HR example. Most important, job satisfaction. So now I'm going to do a job satisfaction. So guys, in this particular case, I'll tell you exactly how I'm going to go about so that you can understand. First, I have this job. Okay, so I'll explain you the model first. Okay, what is a model? What are we going to do? We have a problem with attrition. Okay, I want to understand how can I reduce attrition. Okay, so first I'm assuming that attrition. Oh God, damn. Microsoft guys will never ever improve on this. Always that pointer, you take the pen and it basically goes and gives you that weird thing which comes in. So first you take attrition. Oh God, why this thing comes in? Huh? Okay, and attrition is, we are basically saying that attrition is proportional, to job satisfaction. So job satisfaction increases, attrition inversely proportional. Attrition decreases. Okay, that's my first thing. Okay, which means that shit, horribly. Okay, so if you look at a model in terms of our machine learning language, okay, let me use that. So your DV is attrition, okay, and your IV is job satisfaction. Okay. Now what I'm going to do is how to improve job satisfaction. For that, we need to understand the factors which are affecting job satisfaction or components of job satisfaction. Okay. Uh, so I will have some components of job satisfaction. Okay. So first I will regress this one. Okay. Now, since job satisfaction is a continuous variable, sorry, continuous variable, I will have to use regression because the dependent variable here is job satisfaction. It is a continuous variable. Independent variables are also continuous variables. So I'll do regression. Okay. But before that, I need to check if the question that I asked you, uh, before that, I need to check if there is any multicollinearity, okay, amongst these variables. Okay. If there is any multicollinearity, then I have to get rid of that. तो पहले मैं करूंगा dimensionality reduction, which is factor analysis, okay, FS, of all these variables. If I find multicollinearity, then I'll go ahead with the factor analyze things. If I don't find, just a sec, guys. One second. Okay. Sorry. So uh, then I will go for, so I'll finish that first. Then I'll come up with whatever factors that I get if there is a multicollinearity. Then I'll regress it on the dependent variable. I'll find out if dependent variables has got some sort of relationship with job satisfaction or not. If it is there, then that's good. That's a very good news. And then I will find out relationship between job satisfaction and attrition. So hear me out. First, components of job satisfaction. Check for multicollinearity, which is fact analysis. If not, no problem. Straight away regress that on dependent variable, which is job satisfaction. If yes, do factor analysis and then regress it. Okay, that is linear regression because dependent variable job satisfaction is continuous and all other variables which are components of job satisfaction also are continuous. Okay, once you regress it, then if the relationship is proven significant, great. Then the components go aside and then we will regress job satisfaction on attrition. Okay. And if that relationship is good and significant, we have arrived in life. But that will be logistic regression because attrition is binary. So for the first is dimensionality reduction to check the multicollinearity. Second, linear regression to understand the impact of all the dependent variables, independent variables of components of job satisfaction on job satisfaction. And the third is logistic regression, where you have job satisfaction, which is generally one independent variable, which is continuous, right? Deciding on the attrition, which is binary, which is categorical, nominal, right? So over the logistic. So first dimensionality reduction, then linear regression, and then logistic regression. It's a little complex model, but I'm going to use all the three and then come up with whatever it is. Okay, fire. So if I go to the library, okay, and I find out what are the components of job satisfaction, I get challenge, autonomy, locus of control. I'm sure you understand challenge. I'm sure you understand autonomy. Locus of control is something which is in the realm of your control. Whatever you can do. For example, hybrid working. Okay. If you talk of that, uh, the company's policies on hybrid working are not in your locus of control, but your time management is in your locus of control. So that's the meaning of locus of control. Okay. Job stress, you are aware of it. Routine, you are aware of it. Self-esteem, you are aware of it. So all the libraries and books and whatever, I go through it and I understand that, okay, fine, there are these 6 factors which determine job satisfaction. By the way, the exercise that we're going to do little later, we will have something called employee satisfaction. There's a difference between job satisfaction and employee satisfaction. A job satisfaction, that what you get from the job, employee satisfaction is a little larger and employee engagement is further larger. Okay. So employee satisfaction, variables are going to be a little different. We will discuss that when it comes in. So I said, okay, fine. ये 6 है. First thing I'll do is I'll find out the inventories or test to measure challenge, to measure. We'll have to measure that, right? So challenge, autonomy, locus of control, job stress, routine, self-esteem, सबको measure करना पड़ेगा. उसके लिए I need to have inventories. These are the inventory or test or whatever they call it. Survey, जो भी है. Okay. Scale, survey, all these things are synonyms. So I use it. These are actually there, by the way. These inventories are there. It's not kind of thing. So I measure it and I get something like this. Now P number stands for a passcode number. Okay. This is the score of challenge. This is autonomy. This is LOC, stress. Now stress is high because the number of items in that test are high. So that's why it doesn't mean that stress is high. Huh? Then you have a routine and self-esteem. But just mere looking at this, of course, 10 items are there, but there could be several of them. That doesn't mean that they are highly correlated. Okay, we won't be able to understand that whether they are correlated or not. So what do we do? Okay, find correlation. And here we have the correlation. If you look at this, you see, there is supposedly there is a reasonably high correlation in challenge, autonomy, and routine. Okay, routine. So challenge and autonomy is 0.92, routine and challenge is 0.89, and the third, of course, the third is so all the three are highly correlated with each other. Okay, if I look at uh, LOC, which is and esteem is 0.89. Okay, which means these two are highly correlated. Okay, and stress doesn't have any correlation, high correlation with anyone. Okay, so this is the correlation matrix. Okay, now what you do is which means that there is a multicollinearity, right? Very high, 0.92, 0.98 is like our over the hill correlation, which is 100% multicollinearity. So we need to take care of this multicollinearity. Okay, how do we do that? We will do factor analysis. For that, there's a code, but code I'll discuss later when we'll do it in R. Okay, and this is what you get. There is a $1 million question here. This plot is called a scree plot. By any chance, any one of you, Sachin, Subramania, Subrat, or anyone else, have you heard of this word called scree plot in factor analysis? I'm just asking. If yes, then I'll just go ahead with that. Subrat, Sachin, have you? Sachin says no. Subrat says no. Okay. So first of all, let me tell you where the word scree has come from. Okay, scree as a word come from geophysics. Okay, have you been to the Konkan region by any chance? छुट्टियों के लिए बहुत लोग जाते हैं. A lot of people go on, in Konkan for छुट्टियां. Okay, have you ever been? I'm just asking a very arbit question while teaching factor analysis, which is very odd. Have you ever been to Konkan region for? I'm talking about Konkan in the sense from Mumbai to Goa. If you look at the terrain there, okay, the terrain is like this. Okay, so you have mountain like this, and then the mountain, there's a steep slope, and then sea, correct? Right? This is the Konkan region. This terrain is called scree in geophysics. Understood? So the word is from geophysics, and this terrain is called scree. The type of okay. So why it is called is also known as elbow plot and a scree plot as well. But because it looks like a scree, okay, in geophysics, ye wala na. So this is like mountain tapering down, and then you have sea. Okay, it also looks like a elbow as well. Okay, so that's what why it is called scree plot. Chalo, theek hai. Now, what are the various components of scree plot? Now, these are the components factors, right? So we had 6 factors, na? So it has churned out and brought about 6 factors. But these factors are not those 6 factors. Okay. ये तो उसका क्या कहते हैं उसको? They call it निचोड़ is a word. So निचोड़ है उसका. So for example, all the highly correlated guys will get together and form one factor. And basically, the correlation between and amongst the atoms will form the factors. Okay, which means that if you look at this is factor 1. Okay, you call it PC1, factor 1, RC1, whatever. In R it is RC1, in Python it is PC1. Okay, so this is RC1. Okay, this is RC2 and 3 and 4 and 5th and 6th. Okay, now RC1 is what is this value, and this value is known as eigenvalue. Okay, now you will wonder ये eigenvalue I कहाँ से है? Have you heard this term, by the way, eigenvalue, by any chance? Sachin, Subrat, uh, have you heard? Yes. Okay. Did you understand what eigenvalue is all about completely? Subrat, in next 10 minutes, 99%, and after next 20 minutes, 100%. You will understand what the eigenvalue is. Okay. So I'll go ahead with that. Okay. So for the time, जैसे आपने वो रट लिया था factor loading, I will make you understand. ये भी रट लो भी फिलहाल. So this is basically the eigenvalue of factor 1. This is eigenvalue of factor 2, and this is eigenvalue of factor 3. Conventionally, it says that if you have eigenvalue of one or more than one, okay, one or more, those many factors you should consider. Okay, so since the third factor is eigenvalue of 1, you should consider 3 factors, and 4th, 5th, and 6th are not contributing to the entire thing. So just like in the first case, okay, or rather the second case, remember there are some factors which have not even contributed. So just knock them off. Okay, and here also we'll knock it off. This particular script out we will draw today by taking a data set, and I'll show you how exactly it is done. So the objective of this particular lecture is, of course, understand how exactly how to model it, which we are modeling. Okay, number one. Number two, how to use data dimensionality reduction in human resources. Okay, and how to address the complex problems. Okay, so this is what it is. Right. So how exactly it has come from? Let's understand this. This is the output of the dimensionality reduction. Okay, because script plot said three factors, we have taken three factors. Variable maximization, varimax rotation we have taken most of the times varimax rotation, and so we want the score, so score is true. Okay, this one is f data, the file is f data. Good enough. So now let's understand the uh, the RC1, RC2, RC3. Okay. Uh, so you know what? Challenge, autonomy, and routine. Remember, highly correlated. Okay. LOC and esteem are highly correlated, and stress is independent. So RC1 is formed by highly correlated items. Like वो cost में पता है ना जब so I'll go to the first. In the first one, in the first example, item number one, item number two, and item number four, they were moving together. So they form one factor called customer, customer alignment. Okay, one, two, and four. Then you have three and five. They were moving together. So they formed another factor, which is likelihood of return. In the second case, you remember we did first, second, and seventh. It formed a factor called cost. And likewise. Okay, so same thing has happened here as well. Okay, so you have challenge, autonomy, and routine has formed RC1, which is factor number one. The second is LOC, and so this is what I said. Okay, what next? Okay, now there is a thing called sum of square loadings, SS loadings. Now, what is sum of square? Try and understand that. Sum of square is basically all these loadings, all these are factor loadings. Okay, where have these loadings come from? They have come from error variance. जो हमने error variance की बात की थी ना, सुब्रत, सचिन, and Subramanian, from there it is come. Which you so they are the loading factor loadings. So from error variance, factor loadings were calculated. No? Lambda, correct. This is lambda. This is lambda. Okay, which is factor loading. Perfect, perfect. So, Subrat, all the lambdas squares, sum of squares. So if you square all of them, you will get 2.77. Okay, that is sum of square loadings. Okay, ये loadings है ना, इसका sum of square. Okay, if you square of this, it will be 1.89. और ये 99 का about 1. Okay, approximated है. Okay, so मतलब rounding of error adjusted. Okay, so now you know where exactly the sum of square loadings have come from, right? 2.77, 1.89. Clear? Subrat? Sachin? Clear? Where this 2 points, it is very important. 2.77, 1.89, and 1, where it's come from. I'll just explain this also and then I'll go back. So proportionate variation, which is basically 0.46 plus 0.32 plus 17, if you do, right, it will be 100. Okay, cumulative, this is cumulative variation. Eventually it will be 100. Cumulative is, sorry, it is 94. I'm sorry. So 1 second, I'm sorry. I'll just, it should be 100, but it is 94. Why? Right? Where is 0.06? There were 6 items, right? Okay. We have सबका निचोड़ correlations calculate करके we have taken 3 out. Okay, which means 3 factors are explaining 94% of variation. बाकी 0.6 मतलब 6% में बाकी 3 बचे पड़े हैं. Some variability is left unexplained. Correct. 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 And we will see that little later also. I'll explain that to you. Where exactly that unexplained variability is goes, Subrat. Okay, Subrat and Sachin and Subramanian. Okay. If that is so, you understand this 94. So some variability we will explain. I'll explain you. Where is it? This is the proportion of 94. So 49% variation of 94 is explained by RC1, 33 is RC2, and 18 is RC3. Okay. So cumulative, of course, is 1. Okay, this one is because this one is in turn percentage of 94. So 94, consider 94 is 100. So this is 1, which means 46 is 49% of 94, 82 is 78% of 94, and 1 is 100% of 94. Got it? Okay. Now this is the thing which I explained. Okay. RMSR is 0.03. That's okay. Root mean square of the residuals, which is also very important, which is also very strong over here. Okay. Now I'll explain you scree plot. 2.77, 1.89. Go back. I'll just remove this. 2.77, 1.89, and 1. 2.77, 1.89, 1. What exactly proportional variation with respect to what? I'll tell you. Have you understood this now? This is 2.77, this is 1.89, and this is 1, which you have seen here. Sorry. So, sum of square loadings is eigenvalue in a way. Understood? Subrat, Sachin, now you know what eigenvalue is? Super. So this is the eigenvalue which is come. I'll show you actually in that also. But okay, I would have actually gone back to conceptually eigen kya hota hai वगैरह, but that kind of time you don't have today. And you are application side, so you have to understand that. Otherwise, I would have gone back to eigenvectors. Then I have to start with linear algebra. That will take time. So that's the reason that I'm explaining in a very different way. Okay. Meanwhile, what exactly is proportional variation? I will have to explain that as well. It's very simple. 46, 32, and 17 is essentially, if you take, what shall I say? If you take the total of this, it is 94. Okay. So proportional variation is basically RC1 explains 46, RC2 is 32, RC3 is 17%. That is proportional, right? And the rest 0.06 is unexplained. We need 100% explanation, right? Out of which proportion is RC1 basically. So RC1 ka proportion is 0.6, so 1.6, RC2 is 32, RC3 is 17, and rest 6 is not explained. Sorry. अरे कहाँ गया? Got it? Subrat, have you understood this? Sorry, ये क्या गया? हाँ ये. Have you understood this? Okay, chalo, super. Now what we need to do is we need to understand. Like for example, आपने नाम दिया. Let's say customer alignment. See, the item 1, item 2, and item 7. Sorry, item 1, item 2, item 4. Somebody read it and called it customer alignment. Okay, sorry, customer alignment. The first example. Okay, 3 and 5, somebody read and called it likelihood of return. In the second example, we basically saw the 3 ones and we called them cost. Then IT resources, as Subrat said. Okay, and the third was organization. Over here, again, we have to understand what is challenge. So, challenge is about job, right? Autonomy, it is about job. Routine is about job. Locus of control is your locus of control, not job ka locus of control. Esteem is your esteem, not job ka esteem. Okay, so if you can convert that into some sort of naming, this is what you get. So RC1 is actually can be called as job related factor. RC2 can be called as person related factor, and stress is stress. Okay, and now you have something called 3 factors. So from this, so we had challenge, autonomy, LOC, stress, routine, and esteem. ये 6 थे. Income factor analysis, some of them are highly correlated. So we kind of did a factor analysis, and then now we have come up with factors which are not correlated with each other, which are job rotation, job related, person related, and stress related. So these 3 factors are not correlated with each other. Okay, because we have taken from different things, so we know exactly it is job, person, stress, and not challenge, autonomy, LOC, stress. Stress to hai, routine and whatever. Got it? So now let's so dimensional reduction over. Now, instead of taking these 6 factors for linear regression, we will take these 3 factors for linear regression. Correct? So that's what we do. Now here, I'm not mentioned here, but this is basically satisfaction score. Okay, that we have used another variable, another scale, and measured job satisfaction score. Okay, so this 6 have gone. Instead of that, RC1, RC2, RC3, or person, job, and stress has come, and job satisfaction has come. So we will now regress this, right? Linear regression. Why? Because your dependent variable is job satisfaction. It is continuous in nature. Okay, and that is the reason why we are using a linear regression. So everything is continuous, right? This is also continuous. This is also continuous. So now we will do this. I'm sure you guys know about this. I'll just skip these slides. This is multiple regression, no? X1, X2, X3, and beta is, that, right? This slope. So you know this. I mean, so I'm assuming you know that. So your code is going to be like this. Okay. LM stands for linear modeling. That's a code that we generally use in R. GLM is general linear modeling. Okay, so I'll tell you, GLM is used for logistic regression. Okay, LM is used for linear regression. We call it linear regression. And there was something called POLR that we used in learnability case, proportional odds logistic regression, that is used when your dependent variable is categorical but ordinal. So logistic regression used when your dependent variable is categorical, nominal. Polar, which is that is also known as ordered regression, is used when your dependent variable is categorical but ordered. And linear regression is used when your dependent variable is continuous. Correct? Okay. So code is very simple. You have this small tilde here, job satisfaction, and you're regressing RC1, RC2, RC3, which is the three things that we have observed. Now, once you, yeah, LM is now linear regression. Now, if you notice here, all of them are explaining a very high variation. Sorry, significant value. 10 to the power minus 16, 10 to the power minus 16, 10 to the power minus 16, which means all of them are, and R square, adjusted R square is 81, which is huge. Okay. So all of them are explaining, which means, unfortunately, fortunately, but all of them are explaining. So if you want to increase job satisfaction, सबके ऊपर काम करना पड़ेगा. That's a prescriptive analytics. Okay, that's a prescriptive analytics. So work on all the three, and job satisfaction will go. Okay. Now let's move to uh, logistic regression. Okay, because we have understood this. Linear ka ho gaya. Now logistic regression, why? Because now one thing is very clear. JS, it has been proven that all these guys are explaining JS pretty well. अभी JS और attrition का देखते हैं क्या relationship है. इसके लिए an attrition is binary, so we'll go for logistic regression. So here you have dependent variable dv, okay, which is binary 0 and 1, quit or no quit. You have job satisfaction, which is a continuous variable. Okay, so let's do this. Only one variable we have. So logistic regression. So I said GLM, right? Remember I said GLM is logistic, LM is linear, and polar is ordered regression. Quit is your DV, which is attrition. Okay, and job satisfaction is your IV. Family is binomial because it's binary. That's it. And you're getting this. Since it is logistic regression, you don't get R square. Why? Because R square you get only if you have a method called OLS, ordinary least squares. Logistic regression is based on a method called which one? Anyone knows about it? Uh, Regression can be calculated by two methods. One is ordinary least squares, log likelihood. Also called, correct, perfect. So also called as MLE, maximum likelihood estimation. Okay, it's Subhath is popularly known as maximum likelihood estimation, MLE. So OLS and MLE, and that's why there's no R square here. Okay, so when we do, and this is also significant. Okay, which means attrition is so job satisfaction is predicting attrition. So since you are doing logistic regression, okay, what we will do is we will create the graph, the sigmoid graph, and here we have the sigmoid graph. Okay, so this is basically one is what you call a live, okay, and 0 is attrited. Okay, so your job satisfaction score is suppose 15. You possibly have almost like 0.01% of retention or 99% attrition. And as the job satisfaction score goes up, okay, if your job satisfaction score is 45, which means you are definitely going to stay in the company. Okay, this is what we have. I will stop here so far as PPT is concerned. Now, so done. We have predicted. Okay. Now I'm going to use a similar kind of example in R. So I'll take a database and take you through that. It's going to be very interesting. Uh, till the break, we'll carry on with that, and then we'll take a break if you don't mind, guys. Again, I'm feeling really guilty about it today. Technically, we would have taken a break now, but I don't want to do that. I'll complete the example and then we'll take a break. Then we have web app. Last time, did I show you the web app by any chance? I don't think I showed you. Did I? The web app to calculate attrition. Subrat, Sachin, Subramanian, all three of you were there. So I'll show you the web app also. It's a beautiful thing. I will also show you the image recognition, and then we will spend some time on your this one. Uh, Most important thing is TEE. ठीक है? चलो. So now I'll take you through the. I'll close down this. Sorry, learnability is not something that we are doing today. Let me open the R and start with the job satisfaction case. Okay. Oh, you can't see that. I have to share it, no? Share screen. Super. Yes. I hope you can see my R screen now. Okay. So, guys, I know you are new to R, but you will by now. Subrat picked up very well. Sachin, I think you too also, you know Python, so of course you can pick up. Subramanian, by any chance, you know Python? Subramanian, you know Python by any chance? Oh yeah. So even you will understand it. Okay. Great. Great. So the first is file dot choose. Okay, which means that read. Read is about importing the file. Okay. So I'm saying, hey R, import a CSV file, and R says which file, allow me to choose. Okay, so please allow me to choose. I will pick it up. So I run this file, sorry, I run this code, and I'll get this prompt. I can't see the prompt here. No, yeah, there's a prompt here. Yeah, there's a prompt here. So let me find out where the file I have kept. Possibly it will be there in 1 second, guys. डेस्कटॉप होगा वहीं उठा लेते हैं. जॉब सेटिस्फैक्शन. नो, इट्स नॉट ऑन द डेस्कटॉप. ठीक है, कोई बात नहीं. वेर एवर इट विल बी, आई विल पिक इट अप. XLS. अच्छा, हम लिटिल वरीड फॉर दी. ऑफ कोर्स ये तो हो जाएगा, इसमें चक्कर नहीं है. बट if time permits, I'll show you bots. Sorry, text mining also, guys. If time permits. We didn't do text mining last time, so I'll show you unstructured data analysis. वो भी करना है आज. This is cleaning. Okay, so I'll just quickly run this. So that's why I'll run the code little fast since you are aware of it. Okay. First of all, measurement of central tendency. So I said summary. I've saved it as JSAT, right? JSAT as okay. I'll just show you this data set. What is the data set? So guys, now this is we are talking about employee engagement. Okay, not job satisfaction. Sorry, employee satisfaction. ESAT. Okay. Now, last time in the sense, I'm talking about the last example that we did on PowerPoint. We had this little exotic or nebulous concepts of job satisfaction, which is autonomy and routine and all that kind of stuff, right? Now I'm basically talking about some brass tack stuff. Okay, so you have training, job rotation, secondment, managers, work-life balance, compensation, policies, benefits, all of them impact employee satisfaction. So this is brass tacks, right? Benefit अच्छा है कि नहीं, employee satisfied हो जाएगा. Policies कैसी है, compensation अच्छा देती हो कि नहीं, work-life balance ठीक ठाक है कि नहीं. All of them are independent variables for ESAT, which is employee satisfaction. And then of course, in turn you have attrition, which is yes and no. Okay, so this is the data that we have. Fair enough. Chalo. So let's move. Uh, sapply is one of the command basically just to know what kind of class of variable. Okay, whether it is numeric or integer or whatever. Okay. By the way, summary tells you about mean, mode, median, all that minimum stuff. Mode नहीं आता, minimum, median, mean, and maximum, and third quadrant, whatever. We will need some more information, which you also will get later. Don't worry. The minimum information आता है, इसमें मजा नहीं है. Sapply. So here also we get to know what kind of variable is this, but just sapply will talk about what class of variable. So when you click sapply, okay, you know that employees integer, training is numeric. Okay, only problem is attrition is integer. Now attrition is not integer. Okay, attrition is categorical. In R you call it factor variable. So that's not integer. That's basically so we need to convert that. We will do that later. Okay. Now I'm going to install library psych, PSYCH, basically lot of psych. We did last time. No, last time I don't know. How about our introduction में हम लोग ने psych लाया था. Okay. So I'll tell you what psych does. Okay, describe. Now it's a beautiful thing, and in describe what you get is numbers, mean, standard deviation आपको मिलता है जो पहले नहीं मिला था, median, trim mean, then you will get, more importantly, skewness and kurtosis and standard error that you didn't get earlier. Okay, so describe gives you this. Okay, and if you do head JSAT, you will get the first 6 items of JSAT, which is okay just to see. Okay, a job satisfaction. So employee number 7, 9, 10, 13, 14 का training score, job rotation, just to know. करने की जरूरत नहीं है, just to show you. For loop actually करने की जरूरत नहीं है यहाँ पर, but just because I had done it earlier. There's only one there's only one variable 11, and variable number 11 is 11, no 11 variable. So last variable था attrition, if you recall. So we are converting variable number 11 into a factor variable. That's it. So if you do a structure after that, uh, or maybe you will run this command sapply, okay, you will see attrition has now become a factor variable. Earlier it was, attrition was, if you notice here, integer. Okay, now it has become factor, which means now R is reading that as a categorical variable. Okay, so that is done. ये तो ठीक है, this is not important. This DF summary, okay, is exactly the same thing what this one did. ये, right? So there's another. So by using psych, we ran a library called summary tools, right? Sorry, we ran over here a summary. Okay, so we ran summary, you got this. Describe me, you got this, right? Describe, you got this. Summary, okay, I'll tell you. Summary, we got this. Okay, basic information. Then we ran describe, we got this. Sorry. We ran describe, we got this, which is good. Similar thing, if you can run summary tools, you will get, there's a DESCR. So you get same information, but in a different format. Okay, just to show you. Oh, there's an error. Yeah, in this format, no error there. Okay, second mean, standard deviation, minimum, Q1, Q, same information, some different form. IQR मिलता है यहाँ पर, उधर नहीं था, interquartile range. Okay, that's okay. This is all not so important. Let's head to factor analysis. Okay, so the first is the library n factors. Okay, now what is n factors? It's a library which basically gives a, of course, factor analysis, but it gives a, for the non-graphical solution, the Cattell's Cree test. That is what is more important for us. So n factors is required for that Cree plot जो आएगा अभी. And then you have for core plot and ggplot, right? Both of them are basically to plot. This is correlation plot, this is any other plot. Okay, so I'm loading 3 libraries. Okay, and now of course in ggcorplot as well. Okay, and devtools, I think, yeah, devtools is also there. Okay, now what I'm doing here is, if you notice, I'm subsetting. Can someone tell me this? Anyone, Sachin, you or Subramanian, whoever, why am I doing this? 56. Okay, I'll just show you this list of variables here so that, okay, here you have list of variables. Okay, what am I doing here? jsat.items. Any guess? Any guess? Right? What is this happening here? Are we selecting independent? Super. No, not rows and columns, Subramanian. Subrat says, are we selecting independent variables? We are selecting independent variables because Subramanian, we have to do factor analysis of the independent variables 2 to 9. ये देखो, employee number is first. वो नहीं चाहिए अपने को, useless. Okay, we are selecting training, job role 1, 2, 3, 4, 5, 6, 7, and 8. Super, Subrat. We're selecting these 8 variables now. Okay, and subsetting it actually into jsr.items. So if you run this, you will immediately see one more data set created, subset. Okay, so another data set created here called jsat.items. Yeah, 8 variables. Na? So when we did on PowerPoint, there were 6 of them, na? As job satisfaction ke antecedent. So routine 14 sabta. Okay, so abhi we have 8 variables. Instead of 6, we have 8 here. Okay, चलो कोरिलेशन फाइंड आउट करते हैं, उधर भी कोरिलेशन किया था, इधर भी कोरिलेशन करते हैं। तो लेट्स डू अ कोरिलेशन हियर. Okay, and I'll do a heat map. I will shut down R before I start the other one. So I should. Okay, guys, look here. Same problem we have. Training, job rotation, secondment highly correlated with each other. Manager is correlated with minor correlation hai idhar. Okay, but highly correlated. Work-life compensation, policies and benefit, big time correlated with each other. Okay, so this is the correlation. If you want to see the numbers, we can possibly run a ggcore plot. Okay, and you can see that over here as well. Pairs panel I will run, but will take time. इसके लिए I'm worried. I don't want to waste time today. But pairs panel will give you similar information. देखो, if you run this, look at this. This is what you get. Okay, 90, 85, 84. So work-life balance compensation policies, you know, are highly correlated with each other. Actually, सब नहीं आ गया. 1 second, guys. Just 1 minute. Oh, you won't be able to see this. Sorry. Uh, because it's a. Oh God, what is happening? Share screen. Let's yeah. So you can see this here. Okay. So certainly there's a group of guys who are correlated with each other and so on and so forth. 1 minute. I'm a little worried here. Why are we getting this? 1, 2, 3, 4, 5, 6, 7 ही आ रहे हैं variables. 1 second. Let me run this again. I only hope there is not an issue. So let me run this. ये तो बराबर आ गया अपना. This one is perfect. Yeah, 4. Work-life compensation policies benefits is kind of correlated. What's happening in ggcore plot then? If it is taking so much of time now, I'm a little worried. Again, uh, guides are deprecated. False use. Please use scaling. I think scaling instead. So maybe some issue with this particular panel. That's okay. We can ignore that. No worries. Okay, which means very clear there is a high, collinearity and multicollinearity, and we will have to go for a factor analysis. Okay, so first I'm doing a factor analysis. Okay, so first I'm calculating the eigenvalue by using the correlation, and then I'm creating the scree plot, NSS scree plot. Okay, so let me done that, and let me straight away, let me do that. Let me plot the scree. Okay, this is I'm using correlations to calculate. Look at this scree plot now. 1 second. I'll share screen. Uh, I'm sure you can see my screen, right? So guys, look at this. What is happening here is this is eigenvalue. Also, I called it. Remember what I said here? Okay, there are factor loadings. So factor loadings are here. So factor number 1 has eigenvalue, or you also call it sum of squares. Sum of square of error, right? Somewhere here. Second factor is here. Third factor is here, which is 1. So we should take only 3 factors now. Okay, बाकी तो कुछ फायदा नहीं है. As Subrat already said, they're not showing any variation. And Subrat, now you will understand exactly what we are doing. So since there are showing 3 factors, the scree plot is showing 3 factors, I'm going for a 3-factor solution here. Okay, using Varimax notation, calling it PCA3, and then I'll plot PC. We'll see what are the loadings of PCA3. So this is 3-factor solution of EFA upset, which is exploratory factor analysis. So let me run this and I'll get loadings. Okay, so guys, super. Now look at this. You have RC1. Okay, manager loading is 154 because we saw some little correlation there, if you recall, manager ka. Okay, work life is 97. Huge loadings is, RC1 has. Okay, sum of square loading is 3.6, which is basically square of all this. A square of all this is 2.767. A square of this is 1.002. ठीक है. I'll come to proportional variation, which is this is roughly about 45%, which is RC1, 36% is RC2, 12.5% is RC3, and since it is 92, or maybe you consider 93, Subrat, Sachin, and Subramanian, 7% is unexplained. Okay, you want to see the 7%? I will show you. Now, in factors, what I'll do is I'll change and I'll go for 8. Okay, because totally 8 components are here, no? So I'll go for 8. Okay, now look at this, what happens. So Subrat, Sachin, Subramanian, all three of them. Listen, so we got this 100% cumulative variation. So first is about 3.641. Where is this summa square the loadings? This is 3.6. Look at my cursor. I hope you can see my cursor. So this is 3.6 on factor 1. RC2, uh, can we say RC1 is about compensation related factor, RC2 and job, and RC3 is manager related? Subrat, hold your horses. Hold your horses. We'll come to that. I quite loved it. I liked it. But my first job is to make you all understand factor analysis, and then we will go to the other factors as well. Okay? ठीक है? चलो. So Subrat, now, Subrat and Sachin and Subramanian, have you understood now? Eigen value क्या होता है? 3.6 ये इधर वाला. All the loadings, all the lambdas का square, sum square is 3.641 for RC1. RC2 is 2.766, okay, which is here, 2.7. Look at my cursor. RC3 is 1.008, which is here, okay. All three of them are explaining 92%, okay. और उसके बाद RC4, 5, 6, 7, 8. Look at this. After ये 12% के बाद 2%, 1, almost 0.16%, 14%, 0.13%, 8%. Sorry, 0.008%. So now you know, right? This, look at this entire thing. RC3 the 93 or the 927 would be 93, you can call it. And then RC4, 5, 6, 7, 8 are contributing only so little. And that's the reason that we are taking that. Now you understood. अभी पूरा आइगन वैल्यू का फंडा समझ में आ गया. दिस इज द क्रक्स. इसके बाद I'll straight away go to the rest of the factor analysis. Have you understood this, Sachin? Subrat, Subramanian, can I assume that now you open up the engine room of factor analysis and understood? Having more RCs are not contributing to explain more. Correct. Huh? So now if someone asks me ask you what is eigenvalue, just say that it is sum of square of loadings. Factor loading कहाँ से आता है? Error variance से आता है. Okay. So if that is really measuring that particular factor or not, that's an error variation. Error variation gives you loadings. Loadings square gives you eigenvalue, and eigenvalue gives you the ability to select. Sum of square loading is almost same Subramanian. Sum of square loading is in a way eigenvalue. Yes. Okay. You can see this here, no? Subramanian. I'm showing it. Okay. ठीक है, चलो. So we're going with three factor solution, and we have done the factor analysis. We have got this, which means there are three factors. अभी जरा our friend actually I can send this code to you. You can actually run this code, and later you see how the one second. Let me try. I hope my PC doesn't वो ज़्यादा परेशानी दे दी उसने. So uh, I'll run this, and I'll show you orthogonality. I'm just keeping my fingers crossed. Okay. Uh, oh God, I made a mistake here. I made a mistake of running this. I'll just abort this. Okay. One sec. बायप्लॉट नहीं करना है अपने को, तो ये रन करना पड़ेगा. सुपर, आने का चालू हो गया. Why is you guys are lucky? ये क्या हो गया? Why it is gone? Just wait a minute. I'll show you something immensely interesting. How multicollinearity goes. You have to give some time to me. Okay, and then all three of you will understand forever. जो थोड़ा सा बचा पूछा है ना, वो भी आपको बताता हूँ मैं. Okay, I've used, by the way, what I've done meanwhile is I've used another method. There are three method of factor analysis that I've shown over here. Okay, option 2, option 3, and option 2 and option 3. This I'm using through another package called stats. Okay, why? Because I want to show you what is orthogonality. Yeah, orthogonality is a crux. It is either you call it orthogonality or what do you call it? Mutually exclusiveness. Okay, that is what you're calling. Uh, so it is taking a little time. So please give me maybe about maybe half a minute. I'm sorry. But if you see this, then your entire funda would be very clear कि factor analysis के बाद होता क्या है. Okay, why it is, I think it has come here, but somehow it just gone. uh, Let me see if any which you have to shut down R for the next this thing. So if it comes, then you guys, since you have a background of factor analysis, I thought I'll just show you that post factor analysis, why it is so talked about. Okay, and how is the scenario post factor analysis of all the variables. That is what I'm trying to show here. It's going to take a little time. Actually, I can. आ गया. Good. You guys are lucky. I was thinking that it'll make. Actually, by the way, one more thing. Meanwhile, I'll tell you. The colors. Na, I can also give. I think where I have. Yes, I've given these colors of attrition also. Use the attrition here. Let me see. Yes, yes. Uh, you know what? This is what makes R very, very unique. There are two colors in this particular graph which is appearing, right? Yellow and red. Yellow dots are attrited individual, red dots are live individuals. Because I have included that in pairs panel as well over here. If you notice, JSAT dot attrition, right? So I have taken that also uh, in the pairs panel. Okay. So this is PC1, which is principal component RC1 है ये. अभी you'll see all of them, RC1, RC2, RC3. Yeah, all these factors that we saw here, and I'll just show you. I'm using another method. Yeah, RC1, RC2, RC3 किया था 3 factor में. But later I used 8 factor model and I created this na RC1, RC2, RC3, RC4. So instead of, so the first correlation that we did was about those 8 things that we spoke about. Okay, and that was training, secondment, whatever that you have, right? Compensation, benefits, policies, and all the kind of stuff. और उसका correlation आपको याद है, right? 0.93, 0.94, or whatever is there. So all those 8 factors are subjected to factor analysis that you know about. Okay, and when you churn those 8 factors, what you get is RC1, RC2, RC3, RC4, RC5, RC6, RC7, RC8. Because there were 8 factors there, here are 8 factors. In those 8 factors, you saw the kind of correlations were there. Okay, which is pre-factor analysis correlations. Well, very high. 3 factors were very high, 4 factors were very high, and stress was in between. Okay. Now वो पूरा churning निचोड़ करने के बाद we run entire stuff, and now see the correlation amongst RC1, RC2, RC3, RC4, RC5, RC6, and RC7. That's precisely I'm doing. Uh, since I changed the method, result तो वही होता है. I'm calling it PC1 instead of RC1 because ये PR component, principal component method, which is also the same thing as factor analysis. So I'm doing, because this package is different. That was n factors. This is stats. Okay. So just a different factor I'm using. PR comp is something which is a command that I've given. So look at this. This is PC1, this is PC2. You can see 0.00, the correlation. और सबका पूरा zero आता है यहाँ पर. Entire thing would be zero. So just give me a couple of more minutes. I'm sorry. It should have actually come. And over here, I mean, looking at the distribution itself, you can see it's a zero correlation. Okay. A positive correlation would be in one direction, and negative would be another direction, and fully scattered would be zero. Yeah, देखो. Look at this, guys. PC2, PC1, 0, 0, 0. As it goes down, it is taking time. The machine is taking time, but you will find all the zeros appearing this side. Okay, and this side will be scattered. And so just maybe another minute or so, half a minute. Sorry for this, guys, but I wanted to see the, make sure that you guys see this exotic stuff, which is just amazing if you are interested in stats. Okay, so just or shall we close down Abert, because अभी ज़्यादा बचा नहीं है, just then another 5 minutes. Well, no, 4 minutes actually of the code. Okay, to conclude the case. Because now nothing more is left. I actually draw a biplot also, but that will take a lot of time, so I don't want to get into that. Okay, if you have learned biplot in fact analysis, that, so actually I use this for a lot of other guys as well. Meanwhile, let me tell you, since Subrat, you were a little jumping, you said, one second, I'll just go back. So Subrat, you said RC1 is about compensation related and RC2 is job. So Subrat, actually, you're right. So instead of compensation, I put HR policies. Okay. And the other, you are spot on job. Okay. So RC2 is job, where I've added 2, 3, and 4, which is the column 2, column 3, and column 4. Now, column 2, column 3, and column 4 are what? Column 3, column 2, column 4 are training, job rotation, and secondment, which is RC2. Okay. You spoke about job compensation, but unfortunately, work-life balance has got nothing much to do with compensation, na Subrat? Okay. Uh, and maybe policies, right? So what I'm doing here is, oh, sorry. So work-life balance, compensation, uh, policies and benefits, I'm clubbing them over here and I'm calling them HR policies, right? Which have all the HR policies. Okay. So 2 plus 3 plus 4 is job. 6 plus 6, 7 plus 8 plus 9 is HR policies. And manager to वैसा ही है. You said that, right? RC3 about manager. Okay. Which is manager. ठीक है. So that's what we're going to do in 158, 159, and look at the structure. If you don't mind, all three of you, you're getting it now, 0, 0. Is it clear now? आपको समझ गया सुब्रत, so that I can abort it. And I told you the color of attracted individuals also given over here. So Subrat and Subramaniam and Sachin, with your permission, um, shall you want to see the entire thing? It will take a little time because बहुत आस्ते आस्ते चल रहा है. Or shall I abort and go ahead? If you're ready to wait, I'll wait. Otherwise, I'll move. Whatever you say. All three of you. Actually, my fault. We are already delayed. Is it okay, Sachin, Subramaniam, Subrat, or you want to see? What is the significance of showing classification labels? Uh, Subrat, sorry, classification labels, as in which levels are you talking about? I mean, attrited, non-attrited. Oh, okay, okay, okay. Well, there's no significance as such. Okay. Oh, that classification you're talking about. Sorry, sorry, sorry. So there's no significance as such. I was just Subrat, I was just trying with some code. Okay, and I just tried if I can get it. I got it. That's it. There is not much of a significance, but you can pairs plot me. You can actually show classification labels if you are. Hey, look at this 0, 0 appearing all over the place. You can see that PC1, PC2, PC3. It will continue with this towards the end, right? So all of them. So again, I'm repeating. In the first correlation that we did, you had this manager, whatever, whatever, all this. Uh, Training, job rotation, secondment, manager, work-life compensation factors like horizontally. Okay, and you had the 92, 93, whatever. After correlation, after factor analysis, you get 0. That's what I wanted to show you, which is orthogonal relationship. Okay, that's it. So, shall I stop or shall I skip? Ultimately, it will be 0, 0 all over the place. Okay, what do you want me to do? I think we can stop. Perfect. Chalo, great. Even Subramaniam said the same thing. ठीक है, chalo. So let's abort this. Okay. अरे abort भी नहीं हो रहा है. क्या बंद है? Stop it, यार. Let me see with Dex. Oh my God. It's saying that terminated. Let me see if it takes this command. Unable to establish conversation when executing console input. Oh yeah, okay. ठीक है, because we terminated. ठीक है, no worries, no worries. We'll quickly. It has taken a lot of load actually. Sorry. अभी वो terminate नहीं हो रहा है. थोड़ा बचा है. Little bit is left, but it is not. 1 second. I'm shutting down everything so that we will get a fresh session now. I'll restart it. And then I'll quickly show you the face recognition. और टाइम मिलेगा फिर टेक्स्ट माइनिंग भी करेंगे. Oh my God. Uh, System is struggling very hard. This machine is an old machine. I'm purposely taking this because this is an older version. Sometimes what happens is some of the newer versions of R are behaving a little radical. So that's where. Uh, Job satisfaction eliminator. One second. Okay. I'm good. So I'll just share screen. Uh, okay. So let's do this. I am restarting it, so I need to. Sorry, I need to get the. Sorry, it was not on desktop, right? JSAT is not desktop. Right, right. We didn't pick it up from desktop. I'll pick it up somewhere else. Uh, it was in uh, Feb. Feb. Okay. Machine is really gone slow. Uh, Job factor. Yeah, this one. Sorry. Done. So I'll run the initial code only. Summary memory की जरूरत नहीं है. Describe psych why कुछ नहीं. We have already done this before. Only thing is ये वाला run करेंगे. And then we subset it, right? What are we taking here? EV वगैरह हो गया. We don't have to take run this. I'll straight away go down to JSAT. Okay. And this one and structure. Okay. So HR policies, job and manager. Okay. This three thing. Yeah, guys, just give me 1 minute. Okay. So now over here, what we are doing is I'm also subsetting it for JSAT1. Why? Because I'm deleting 1 to 4 and 6 to 9, which is 1, 2, 3, and 4. Why am I deleting it? ये वाले. Employee number not needed. Training, because we already added this, na? Training, job rotation, secondment add कर दिया है. So we don't need. We also don't need work-life balance, compensation, policies, and benefits because we have added them. Okay. We need ESAT for sure and we need attrition for sure later. So I'm just adding them and running the code. Okay, so now if you see the structure, you have manager, which Subrat said earlier. You have ESAT, which is already there. Attrition to chahiye. Job, which Subrat said earlier. And Subrat had called it compensation, so I'm calling it HR policies. Okay. So that is something. So just straight away go for regression. Now I said linear regression के लिए LM होता है. Okay, linear modeling. ESAT is a dependent variable. Manager, HR policies, and job are the independent variables, right? JSAT is a data frame. Okay, this one. So let me run this and I'll look at the summary. See the summary, guys. Now here it's very clear. Manager is not impacting. Okay, HR policies not impacting. It prescription analytics, guys. Job big time, 10 to the power minus 16. So highly significant. Okay, R square is 0.40, which is low, but chalta hai, no worries. So now it is very clear. If you want to increase jobs, prescription, you want to increase job satisfaction of your employees, job के ऊपर focus करो, training ज़्यादा करो, because ज़माना है upskilling, retooling, reskilling का. Focus on training, focus on secondment, sorry, And what we saw here is, the first three things: job rotation, training, and secondment are the ones which are very important for the employee satisfaction in this company. शायद पगार वगार ठीक ठाक होगा, ठीक है? So this is what we got the prescription for sure. Let's go for, वो हो गया now. LM कर लिया. We know that job is more important than others. Let's go to GLM now. GLM is logistic regression. Since it is established that ESAT is and job is related, we know that. Now let's the dependent variable ESAT becomes an independent variable ESAT here, and dependent is attrition. It is binary, so we go for logistic regression, family binomial. So we run this and look at the summary. Uh, Look at this, highly significant, which means job satisfaction is predicting attrition. Okay, because it is highly significant, which is fantastic. Okay, now we have to create a plot, right? The sigmoid plot. So let's attach the same JSAT1. Okay, ye wala. Okay, and let me plot it. Okay, and let's look at the curve. So here you will get ye curve aa gaya. Now, if you go to client or your boss, suppose if you are in HR, they'll say, "What is this nonsense? This is attrition. I can understand. Zero is attrited, one is not attrited. Satisfaction score is 10 and 70, but this curve doesn't make any sense. So you have to make it proper. For that, I'm going to use fitted values. Okay, so I'm going to use fitted values, a library called ggplot2, which actually will give you a better plot compared to what we did just now. Okay, so there's nothing but smoothing. So I use geom smooth. Okay, geom smooth is basically smoothing. So this geom word comes from ggplot. Okay, and ggplot has got, so this is what you get, smoothing. Yeah, look at this, guys. Okay, one second. I'll blow it up. So for that, I need to share entire screen. I can't do it on one. Okay. Now you can see this. Okay, look at this now. Completely smoothen up. Okay, and you see all the data points, but still, not very clear. Okay, where exactly it is. I'll further enrich it. So for that, I'm using Plotly. So oh God, again I made a mistake. I already have it. I should not have installed it. Okay, one sec, I'll just save it so that next time I don't make. Okay, so if I run Plotly here, again it will install. There was no need to do that. Okay, so if I run the library called Plotly, and uh, I'll it will come now here. That my mistake, guys. I'm sorry. I should not have, because it will take further more time to. Uh, हाँ, ये installation चल रहा है. I could have skipped it. So now if you see the kind of smoothened graph comes over here, beautiful. And now you'll know the power of Plotly, the interactivity in such kind of cases. Just 1 minute, one not half a minute. It should go now. If I wouldn't have ran 198, it would have come immediately, because installation will always take a little more time than invoking. Install in package source Plotly. कर रहा है बेचारा मेहनत, but yeah, successfully packed. Done. Now it will automatically run the library. Hest, Hest. If you're in too much of Hest, you actually Murphy's Law. And it's a long, installation, unfortunately. Plotly takes a lot of time. Very sad. I'm worried for my next application as well, because in that also it is. Shah. And where this is the last code actually, write.csv, because you'll get the new data. But and let me see if we can abort it. It has gone in the loop. That's why it was not getting aborted. Oh God. सब जद्दोजहद वेस्ट हो गई. Bad day today. Anyway, guys, what we will do is we'll take a quick break and come back in 5 minutes, not 10. Uh, Meanwhile, I'll ensure that everything is done and then we can start. Okay. So, Subrat, Sachin, just take a quick 5 minutes bio break and come back. Okay. And then we will try and finish as early as possible. Huh? Please. Yeah, guys. Uh, I hope you all are back. Okay. So I'm just running this quickly, and yeah, this is where I made the mistake. Object P is not found. Doesn't matter. Oh God, now what is this? That it one not found. Yeah. Listen, guys. So this is what I wanted to show you. This is the power of Plotly. So we got the yeah. So look at this now. You actually move. So for example, somebody with ESAT of 42, his probability of attriting, sorry, retention is 61. Attriting would be 39. Somebody who has a 62 JSAT score is 98% sure that he will stay with you. Somebody who's got a power of 4 or sorry, a score of, so you get the entire stuff over here. That's what I wanted to show you. Okay. That's a power of Plotly that you can use. And eventually you can just write .csv. So if you click on this and go to files and see this 911 created just now. So click on this import dataset, and then you will see uh, the list what I showed you just now. Of course, you get just the same thing. So yeah, so this is ESAT. Somebody with ESAT score of, this is the employee number, right? Whatever that you have, and this is the different ESAT scores with probability of retention. Okay, so ESAT 13 is very less, so almost like what 8%, and so on and so forth, right? So this is yeah, 13, 14, 1%, whatever. So this is actually 0.8. So 1% will come here with 4. Okay, and that's what it is, which means 14 score of satisfaction so low that the person will quit anytime. This is what we are getting eventually. Okay, so that is what, so far as this particular uh, thing is concerned. So we started with exactly replicated the factor analysis thing that we learned. Okay, I think a lot of fundas are clear now in terms of eigenvalue, scree plots, loadings, lambdas. Okay, so those things are very clear. So let's quickly do something, and I'm just keeping my fingers crossed. I hope it should work. So first I will run, so I'm going to show you two applications back to back. Okay. And then possible we'll do text mining, and whatever time that we will just keep on showing you different applications. Okay. So the next is going to be web app. No, we'll do emotion recognition if possible. Okay. So I'll just quickly tell you about this, how this was developed. And this is extremely unique, both of you, Sachin and Subharat, extremely unique. So I'll tell you what. There was this about 1.5 minute of story. So there's this, a little around COVID. Uh, there was this, company. My one of my colleagues, in the sense, somebody who is reporting to me, became HOD there, head of the department of HR. He said that we are interviewing someone for a particular position. He has a 1.5 year of gap in his CV, but when we asked, he says he was working for a startup. He gave us a number on which we called, and that guy was working there, which we checked on LinkedIn that the guy is genuinely working there. And apparently, he said that he has 1.5 years working, but then there was some issue. That's the reason that, I mean, whatever reason that he has given. But this guy said that, though he has told us everything, we are not convinced. So, would you please help us? I said, okay, please go ahead and do the following. Have one more round of interview. In the first phase of interview, ask him very easy questions: hobbies, passion, classic HR stupid question. Tell me something about yourself. Get all those questions and let him answer this. So while answering this question, take it photographs. Now this is where the interest starts. Take his snapshots, take the screenshots of the of his face. Cut. Then start hard hitting questions, finance particularly. And when you answer those questions, I want as many screenshots as possible. I'll select which screenshot to take eventually. And then I use this particular application, compared the emotions. I'm using machine learning in this, compared the emotions between the two. And then I realized that, my God, there is definitely a huge difference between the emotions before and after. I said, there's some gadbad, right? Do something and don't, I would not recommend taking him. So this is the story. Now I'll tell you, I can't use those photographs here because of the confidentiality issue. But what I've done is I have taken photographs which are generic, okay, which are generically available in the, so which is basically and close to your heart. So a Bollywood star, okay. So this is my training machine learning, है ना? So I'm going to use Amir Khan here, okay. This is my training set, okay, and that's why I've written Amir. You can see my cursor. The folder is called Amir, and if you click on it, I hope it works, huh? Because today my R is not doing really well. So they're taking so much of time. Yeah. So look at his face now, your nose, ears, whatever, whatever, right? And there are a couple of other photographs also. I'm going to use as a train set. Okay. I'm also using another one, which is Madhuri Dixit. And in this also, these are the training set. So I'm going to train this algorithm by using an image processing tool, right? So, oh God, ये क्या हो गया? Okay, so look at her face. This is the way algorithm would be trained. That the way, whatever is there on her face. That way, um, that's how this particular person's name is Madhuri Dixit. Two things happening in this. Another company came to me and they said recently, they said that we are using hybrid working now. So about 2,000 guys will be logging in from whatever. How do we know that it is Subrat and not Subrat's brother or father or someone else is logged in? So looking at the face, you should be able to recognize the name of the person. So that's another challenge. So one is emotions, the other is name. This particular takes care of both. Okay, so this is basically a training set, okay, which is situated on the desktop here in images. Now this is the testing image that you have. I'll just open that for you. Okay, now nowhere it is written on this particular page that it is either Amir Khan or Madhuri Dixit. Okay, nowhere. It is test.jpg, and these are the different images, okay, of both of them, and little different, एक angle में है or whatever. Okay, so that is what the preamble is. Now I'm going to use some very interesting packages here. Well, if you know about the image processing and all these things, there are only five guys in the world who have got the largest collection of images, and those five guys are Amazon, Microsoft, Meta, Google and Apple, and maybe Geo now because Geo has been collecting a lot of data. But at the moment, five. So I alone, as an alone guy, I can't do it. I have to take help of any one of these guys. So I'm basically taking help of Amazon Web Services, and I'm using my own cloud for that. Okay. So pause. If you notice here, R apparently has got a lot of packages, and that is also fantastic. If you learn R well, then I'll just show you here. AWS. Uh, Amazon Web Services offers some fantastic packages. AWS Analytics is something which I like. POS Analytics, basically, package for Amazon Web Services. I'm going to use POS at the moment, but there are several other POS, machine learning, and all that kind of stuff. Terrific packages. Okay, so I'm going to use POS. The moment I run POS, it will be a tick mark here. Okay, and I'm going to use another package called Magic, which is for image processing, and I'm going to use tidyverse, which is basically data manipulation. Okay. Now I'm opening my own cloud. So there are the keys. Okay. Uh, I'm using a recognition, which is basically a function of recognition, image recognition, which is a function of pause. Okay. Now let me create my own collection on my own cloud. So I create this called R images. Oh yeah, something already exists there. Okay, chalo. We will delete that first. Okay, no worries. Okay, let me run this again. Okay, so I'll run pause magic tidyverse, opening my cloud using recognition. I'm creating collection, which means I'm opening up a folder there. Okay, uh, now I give a path. Okay, so generally what guys we do is I told you read.csv करते हैं ना हम. Okay, and we, so here what I'm doing is I'm giving a path to my computer that, oh, hey guy, to R of course, to go to my C users Rajesh desktop, और वहां पे images folder में ना जो भी है उठाओ and upload it on my cloud. Okay. Now there are 6 files in that, so I have to run a for loop. For each and every file, I have to code. But if I have to get all of them together, I'll run a for loop here. Okay, so those 6 files would be picked up from here. Okay, and they should be called as R images on collection ID, which is on cloud. So I'm calling it collection ID on cloud. It is called. अच्छा ये हो गया. अभी I am picking up my test.jpg also. You know the other जो test वाला है. ये तो train images गई है. अभी test वाले भी डाल देंगे ऊपर. Okay. And this code, of course, I'm not going to get too much into it because it will take time to explain. We don't have that kind of time. But I'm going to detect faces now, okay, in the images. We need detection also, no, for that. So here detection hai, and then I'll get into all the attributes, which I'll show you what are the attributes. So we will see that as well. And I hope, yeah, it is detected Madhuri, it is detected Amir. Okay, look at this. Both of them have been detected. ओके, एक मिनट है, यहाँ पे एक annotated करके लिखा है मैंने. So I'll just see to it that, yeah, annotated is this folder is empty. So what I'll do is this particular picture that you saw will be now exported to annotated. Okay, that also I'll do. uh, Here is image write, which means send the image. Okay, we write.cs, we know I'm writing the image. Okay, so writing the image also, so वहां पे भी गया है. Now look at the attributes. So what are the attributes? Angry, calm, confused, okay, and then disgusted, fear, happy, and sad, okay, and surprised. It also gives you age, lower and higher as well, so almost the same. But if you look at Amir, his angry score is 0.15, calm is 98, which is very calm score on this. 15 is confused, and so on and so forth. If you look at Madhuri, for example, anger, of course, she's laughing all the way, right? So it's happy. 98 is happy. Okay. Amir is not happy because you can't see that happiness over there. You see calmness over there. Okay. Uh, a bit of sad, also very, very small sad tinge to his this thing. Fear थोड़ा बहुत है 8 point sorry 5.9. So that's what it is basically measuring. These are the attributes that is measuring. Now this is, and it is recognized as Amir. So the algorithm did know it. Basically machine learning है, so first learned those three, सिर्फ 3 images में उसने सीख लिया और वन में predict कर लिया, and that was so accurate. Okay, Amir and Madhuri, because the spellings have been picked up from the folder के जो नाम लिखे थे वहीं वहीं से. Okay, images के folders में नाम है ना ये वाले. Okay, over here we had given name, otherwise nowhere the names are there. This is Amir, this is Madhuri. Okay, from here they have picked up the name and give it over here. Okay, in test image. So likewise, we have used it for two different, purposes, as I said earlier. Okay, so I wanted to show you this, absolutely futuristic. Tomorrow, if you're entering in the organization, there are cameras all over the place. They may take your pictures and they may say that your engagement levels, looking at your pictures, your engagement level कितने हैं, वो भी कर सकते हैं. अच्छा, by the way, quickly I'll show you that as well. So annotated में export हो गया वो. Yeah, this is the file, which is the same thing that I showed you. So I'll just open with anything. I mean, you don't have to really, even pen भी चलता है. Okay, so look at this now. I mean, same file. Okay, scores भी लिखे हुए हैं यहाँ पर. So this is what I'll just delete this because next time I'll require. Okay, so this is the one application that I wanted to show you. Now I'll show you another one, which is the text mining. Sorry, which is a web app. Web app के बाद we will do the TE ka score pattern, TE ka pattern, and then if you want to leave, you won't leave. I'll record it. I'll show you text mining in the rest of the time. Okay, but TE तक तो रुको, उसके बाद it's your choice. Okay, by the time it will be 9:30. So let me 1 second. So let me show you the. So okay, what I'm going to show you now has two parts to it. One is the modeling, and the other is the app. Okay, so first let me do model. 1 sec. So where's the model gone? TCP/IP. Yeah, model is here. Okay, so I'll just show you quickly model. As usual, importing libraries. So I'm going to use random forest here. By the way, what I'm telling you is basically dashboarding by using apps. And what is it? For example, tomorrow you go and tell your bosses that, this is, I'm doing a course and this is what was told to me, that you have this entire R which predicts, तो पूरा run करो and all that kind of stuff. That guy will get wild at you because इतने लंबे लंबे course कौन run करेंगे? So those guys, CHROs and CXOs and all that kind of guys, I included, I used to be one of them for about 13 years. What you need is you need something which is ready made on the screen, a dashboard. Maybe I'll enter few letters and I'll words and I'll get it, or figures and I'll get it. I don't want to run the code and all. So this is what I'm going to show now. I'll show you the database also in a moment from now. So scale I'm going to use random forest. So basically we're predicting attrition here, and that's the reason that random forest. Then I have a caret for basically partitioning. As usual, read.csv file mangala under. So we'll run that. The file is here. Shiny 4. Yeah, this is the file. I'm going to use a shiny. Yeah, this is the data set. So I'll just show you the data set also. We have performance category in this, right? Which is an ordinal 4, 5, 6, 1, 1, 2, 3, 4, 5. Average increment rate for last 4 years. Experience factor. Let me explain you what is experience factor. Experience factor is nothing but number of years of service multiplied by number of jobs change. So if you have 1 year in service and 1 job, it will be 1. So why? Because attrition, logically, देखो ना, somebody who has changed 5 jobs in 10 years and somebody has changed 1 job in 10 years. Who is more likely to quit? 5 in 10, na? So that is what the experience factor. Feature engineering, 2 different features. We created 1 feature of experience factor. EE for employee engagement, NEOC is ocean variables, and attrition. Currently इतना data लिया है. You notice इसमें मैंने the unique number of employee ID is not needed for this, and you'll understand very soon why it is not needed. Okay, so this is the data that we are using. Okay, as usual, partitioning 80-20 done, training set, testing set. Okay, so हो गया सीधा फिर random forest पे चलते हैं. So this is why attrition. Okay, tilde I'm putting dot here, मतलब all the variables जितने भी train set में dots है ना सब ले लेना. And you guys know random forest, so I'm going to use 500 trees. Okay, over here. So this model I'm building now, this is data science. Okay, now I build the model, I will save it as model.rds over here in this particular file. Okay, so let me 1 second, ये थोड़ा सा आगे है. So let it go and then I'll save the model rd as model.rds. Okay, done. So I'll save this as model.rds. Okay, pura model तैयार है. We have kept it. Now I will go to the app story. Okay, and this is the app story. So if you look at this, I'll just talk. So I'm getting model.rds in the app. Okay, as a backend. Okay, this is the user interface UI. So user interface में you require a header ना. ऊपर क्या लिखा होगा? UI UX is basically dashboarding, right? So ऊपर attrition predictor लिखा होगा. Then you have a sidebar panel बाजू में. Okay, sidebar panel पे you have all this performance category, increment rate, all this kind of stuff. So this is essentially as called as UI. Okay, then you will have the server side, and eventually you have the app. Okay, so there are 3 parts of it: UI, server side, and app. This is the server side. Server side will pull the model. I'm not again. I won't be able to explain the entire code because we don't have time. But I'm basically pulling the model here and putting this to prediction. Okay, rounding off, all that kind of stuff. Probability is going to be calculated. Okay, so I'm using that. So this is basically the model. I'm going to pull the model here and predict. This is prediction. Okay, but इसमें होता क्या? I have to just run the app. The moment I run the app, okay, you will get something like this. Sorry, 1 second. You will get something like this. Okay, now your CHRO, CEO, whoever is there, Subrat ka naam aa gaya, Subrat Mohanty. What is his performance category? 5. Average increment, Subrat Mohanty has been getting about 150%. Brilliant guy. Experience factor less. He's been working in the organization for so many years and whatever, 12. Employee engagement is very engaged guy. Okay, neuroticism is less. So whatever the scores are here, you can directly import them also. You can put them also. I'm just changing this scores. You can use a slider here as well, by the way. Openness is high, agreeableness is high, consensus, I say random डाल दिया, consensus है. Then I submit. So 83% probability that Subrat will stay, 17% probability Subrat will quit. Done. Another person. Performance category 3 or maybe 4. Average increment I'll put down. Experience I'll just purposely I'm kind of moving some variables down, some variables up. Conscientiousness I'll get down. Maybe neuroticism I'll go up. Okay, extroversion down, whatever, and say submit. 20% probability that the guy will quit a live stay, 80% probability the guy will stay get separated. Obviously, because एक तो उसका इंक्रीमेंट रेट कम है, उसका neuroticism ज़्यादा है, engagement level कम है. Category 4, in spite of category 4, is not getting good money. So logically also fits in low conscientiousness and all, which means he's quitting. Sorry, 80% he's quitting, 20% is live. Okay. So, instead of running all those codes again and again, take a list, CSV chapo, fir batao. It's a long process. And that is the reason. So I took only data. I didn't take the employee numbers. Just historical data, पीछे से upload करो, model run करो, सीधा app run करो, you've got this. Okay, you can put some color and all that kind of stuff is not very difficult. Attrition predictor, get in the center, name of the company, logo, shogo, everything you can put in UI, and this will become a nice dashboard of calculating attrition. Got it? Understood, guys? Sachin, Subrat? Okay, great. So this is another one which is going to be, I wouldn't say futuristic. This is here and now. I mean, we can create this at any point in time. No big deal, right? So this is something which I wanted to show you. I mean, text mining batana, but uske pehle I'll just take you through the TEE. Okay, so just give me a moment. I just stop share. The most important part of the meeting. I'm closing down R. I'll again reignite it later. Uh, Now I'll show you the TEE format. Okay. So as I said earlier, okay, there is no um, R, okay, and there is no figures and there's no numbers. So you'll have something like this. Can you see my screen? Okay. Subrat and Sachin, is it visible, right? Yes. Okay. Great. Thanks. So only this is one. Likewise, there will be two questions. Infratech, it's a case lit, as I call it. Infratech is a new age startup, whatever. They're looking forward to recruit quality personnel. Lately, because of excessive demand and required skills, recruitment of quality roles is a major issue. Resources do join, but there are infant mortalities. That's where the question starts. Employees join and quit within 6 months. Initially, the HR had thought it is because of compensation, but definitely not. It is compensation. Soon, she, as in the HR, had realized that those who have been given higher compensation increase also leave within 6 months. I'll come to that, Subrat, approach note. Okay. Head HR of infrastructure now concluded that she needs to whatever. So write an approach note in terms of how will you carry on this assignment and what are the things would be there in that and how will you conclude. So first of all, you'll have to mention about various variables. This is from your domain HR knowledge. That which variables could be contributing to attrition. Like for example, just now I spoke feature engineering किया ना, अभी experience factor करके लाया. Okay, number of jobs changed. Did I speak about inorganic and increase in? I think I spoke. Organic increase in salary and inorganic increase in salary. Right? Organic increase in salary is when you are in the organization. Oh, I didn't speak about it. I'll quickly tell you. So if your salary is say today 25 lakhs, okay, and you started your life with 5 lakhs. So between 5 and 25, which is 20 lakhs, is the increment in your salary for in the last 5 years for the sake of discussion. Okay, so you would have earned some increment in the organization. And when you hopped, you will have got little 20% increase. That's first, you're on 10 lakhs. When you hop, you will get some 14 lakhs in some other company, right? That 4 lakhs in inorganic increase. Okay, and within the organization, whatever increase that you get is organic increase. So you join a company at 5 lakhs, from 5 to 10 you move within the organization, so that 5 lakhs is organic. Okay, then 10 to 14 you jumped, so 4 lakhs is inorganic. Okay, Now, if inorganic salary exceeds organic salary, that shows that your possibly, performance hasn't been really as good as it should be. So these are the feature engineering aspects of HR. Okay. So likewise, experience factor, salary, inorganic, organic, all that kind of stuff you have to mention here. Then, oh, there will be location change. Okay. Uh, there could be a spouse working in one location, so obviously the person will go back to that particular location. That is also there. Compensation could be there. So there are several variables which could be contributing to attrition. Then you have to decide, identify, and define the independent and dependent variables. So again, same thing. You can actually say that okay, dependent variables are attrition, but you can also say that yes, it could be like, for example, just when we spoke about you know logistic and linear regression we use, right? So initially you say that okay, fine, uh, person satisfaction would be your what is exactly inorganic salary increase? You couldn't get it. Inorganic salary increase is what you get, the increase that you get between the jobs. If you're working in one company, Subharat, and you move to the other company, you will get 20% increase, right? So that 20% is inorganic increase. And if you are in a company and you keep on getting increments year on year, that is organic increase. So within the company, you get organic, you jump with inorganic, again you get organic, then you jump, so that is inorganic, likewise. So the postulate is that if your inorganic increase is more than organic increase, you get organic increase because of your performance, na Subrat. Inorganic increase in how good you give the interviews, okay, or whatever. So if your organic increase is more than inorganic increase, which means that you've been really performing very well in the organization. If your inorganic increase is higher and organic is low, which means you're possibly jumping and taking advantage of the market, right? So that also you can use somewhere, not here, somewhere. Okay, then profiles of the candidate who quit early attrition. Okay, as in what kind of candidates would probably quit early? Again, location change. If you are hiring someone from Bangalore in Mumbai, or vice versa, probability is more that a person will opt. Okay, because everybody doesn't want a discomfort. Okay, there are several other things that you can possibly think of. Okay, which the person would quit. Okay, someone who's getting possibly not finding a job, taken a job salary cut and join the organization. और 6 महीने में उसको वापस अच्छा सैलरी मिलकर वो भाग गया. ओके, सो सैलरी करी, सो यू एचआर वुड बी वेरी हैप्पी यार, रिक्रूटर, कि उसको 10 लाख मिल रहा था, मैं 8 लाख में लाया. अरे भैया 8 लाख में लाया, लेकिन द मोमेंट you'll get 12 lakhs he'll go. Okay, so that could be one of the reasons for attrition, which means that HR is cutting corners, recruitment is cutting corners while recruiting. That could be one of the reasons. So a variable over there would be an average increase offered. Okay, so an average increase offered would be, it should be 20, it should not be too high, it should not be too low. That's what I meant. Tools that can have, these are machine learning tools. Okay. Sources of data, where are you getting this? ATS, HRIS, sometimes finance, joining bonus and other things. So wherever you get it from, and any other information that you can take, and you have to prepare a proper note that this by addressing this kind of question, that this is how we're going to run the entire assignment. Understood? Subrat, Sachin, any question? I hope this will give you a little relief, because there's no R code in this. There are no numbers here. I'm not asking you to crack a case by giving numbers and all. I could have done it, but this is something that you have to write in about 500, 600, 700 words, whatever words that you can use. Okay. By the way, now too many things. For example, if you're identifying, deciding, define dependent, independent variable, you should also, is there any sample which you can show? Subrat, I don't want to do that. I'll tell you why. Because I'm throwing it open for your imagination. Okay, the better you understand, the better insight you give in the approach note is better. There are no right and wrong answers. Okay, Subrat, uh, possibly you and Sachin would write completely different, but you may get same marks. Okay, you also mentioned dependent variable and independent variable का class क्या है, right? There will be categorical variables, there will be uh, and reason why are you selecting, say, classifier, because the dependent variable is classifier. How you approach the problem. Correct, correct. But write a little detailed note, because I think this is about 30 marks question. So you have to really put forth a lot of thought and then come up with the note. Right? As much information as possible we can give. सो डिपेंडेंट वेरिएबल क्लास क्या होता है? आउटलाइन द वर्कफ्लो इन डिटेल, करेक्ट। जैसे कि फॉर एग्जांपल इफ यू आर सेइंग दैट ओके फाइन आई एम गोइंग टू यूज logistic regression or support vector machine or all the classic files. Why? Because your dependent variable is um, categorical in nature. Okay, or you if you list down all the variables, you can say that okay fine. After listing all the variables, I'll go for a correlation. If there is high correlation, then I'll use in dimensionality reduction. In dimensionality reduction, how do I go about it? Maybe you can mention a little more over there as well. So hypothetically, maybe they reduce down to three or four or five or whatever, which are mutually exclusive. Okay, so for that, which machine learning algo will you use? Then what you do, and so on and so forth. Maybe you can say that it's an early अभी ये तो mortality का है, but there's something called joining pulse which is also collected. Okay, now joining pulse का भी कहीं से तुम ले सकते हो, because joining pulse which is an engagement story, so that is a continuous variable. So you get all the variables which are related, which you have picked up, like just like exactly what we did today. So all of the variables are independent variables. Joining pulse would be dependent variable. You regress on that and you find out your pulse is impacted by what, and then find out the relationship between joining pulse and attrition. If there is any relationship, use pulse as the most important thing. So say that next time pulse is very important. So the moment pulse is down, be rest assured that this person is leaving. So try and restrict. That's a prescriptive algorithm. So all these things, what I told you for this particular problem will not come, but this particular problem, likewise you create a complete note that this is how one can go about it. क्योंकि जो पढ़ के बोलेगा अरे यार परफेक्ट, ये हम लोग लगा देंगे चलेगा, उसके बाद यू रिक्वायर कोडर एंड मशीन लर्निंग है उसको लगा के कर सकते हैं. So this is basically what cookbook, okay, or a cheat sheet or a cookbook, whatever you call it. You create that. Is it clear? Sachin, so you there? Yeah. Sachin, you got it? When we say sources, we can refer to required databases. Yeah, HRIS hai, ATS hai, maybe finance database or whatever that is. Is it too difficult? Am I asking for too much? Sachin Subrat? Because I want to understand what you have learned in these 4 sessions in terms of insight. Okay. और कोडिंग वोडिंग तो सीख लिया ठीक है, but apart from that, we've been telling a lot of things. Okay, guys. So we're not stopping here. Uh, if you want to log out, you can log out and see the recording later. I'm quickly going to show you. I'll try and attempt to say, you have done NLP and text mining, right, guys? I'll take this 5-10 minutes. Have you done NLP text mining? Subrat, Sachin? Great. So I'm going to use NLP and text mining. I'm showing to you sentiment analysis. You have done sentiment in this one. R तो नहीं किया होगा ना? So HR में application बता रहा हूँ मैं अभी. Okay, Sachin and Subrat. Again, I repeat, if you want to log out, please, my sincere apologies to both of you for the delay. If you want to log out, you please log out and see the. Oh, you done on tweet data. So I'm going to do it on engagement HR data. Okay. So again, I repeat, you're free to log out if you are getting late. Otherwise, we will just uh, do it over here. Just a second. Uh, One second. I'm just looking at which one to use, right? Which code to use. There's so many codes here. And this is one second. Okay. So I'm going to use some packages here. Susanate, Libridate. All of them are not required. It was required something else. Okay. So here I'll import the engagement data. So read.csv is import the file. Okay. So I'll just import. I'll show you the file also. One sec. I'll show the file here. Uh, yeah, this we don't require. engagement file. I'll open this. By the way, Surat, since still you are there, these are the actual statement given by employees. Huh? Actual statement. I've not cooked them. Okay, there are quite a few of them. I think how many of them? About 1,000. बहुत था मैंने trim किया ये data. Okay, so I'll just show you. Share screen. Uh, okay, so see this. These are the positive. What are the positives in this organization? So this is the response that I've got. Okay, this entire file is about that only: democracy, freedom to express, responsibilities is good, work culture, whatever that you have over here is written over here. Okay, so I'm going to import this file, and so much of look at the sentences कितने लंबे लंबे हैं. Okay, so I'm going to use that. uh, I'm coming back to my R screen, sorry. Okay, so we're back to R. So I'm importing that CSV here. Okay. uh, oh, Sachin, you are also there. I thought you were logged out. Okay, so I'm importing this same file that I showed to you. It's on desktop. It's called engagement statements here, this one. Okay, so if you look at the structure, it's very clear, only two: employee ID and positive. Okay, so I'll knock off the first, we don't require the ID. So I'll knock off the first, comma के पहले rows, comma के बाद column, minus C, column number one, minus concatenate column number one. So one number को delete कर दो. Okay, now this takes some time, so I'm worried if it happens fast, I'm lucky. Sentiment score. Okay, so before I get into this, there is something called, okay, I'll just tell you about this particular get NRC sentiment. Now, this is the most important thing that you have, okay, in R. So, for example, if there is a word called shout, if I want to understand what does it mean, okay, it actually means, on various, parameters, the word shout will be assessed. Okay, so over here, you get shout means anger. Okay, shout means surprise. And yeah, that's it. Okay, anger and surprise. So you shout. Sachin and Subrat, can you tell me some other word which you would want, any verb which you think that you want to see? What does it mean when it comes to sentiment analytics? Okay, any word that comes to your mind? Anything, whatever words, a verb which will have some emotion attached to it. Balance. Let me see balance का क्या आता है. I don't think balance is a verb, but let me see what it says. Okay, balance. Balance तो नहीं होगा because it's a verb, ना? Yeah, it's a positive. That's it. Correct. Balance is positive, right? उसमें anger नहीं है, anticipation नहीं है, disgust नहीं है, fear, joy, sadness, surprise कुछ भी है, but it's a positive word. Okay. Sachin, anything else from your side? I'm just trying to make you understand how exactly the engine room works. Let me see, care का क्या आता है? No, care doesn't have anything. Okay. Anything else that you can think of? Work is neutral. Work is neutral. वर्क को सेंटिमेंट्स नहीं है ना कुछ. बैलेंस है सेंटिमेंट. ओके, एनीथिंग एल्स? इसमें सपोर्ट इज आल्सो न्यूट्रल. आई डोंट थिंक सपोर्ट विल हैव एनीथिंग. नो, सपोर्ट इज न्यूट्रल. इसमें हैप्पी नहीं है ना, सो लेट मी पुट हैप्पी हियर. लेट्स सी व्हाट हैप्पी को क्या क्या आता है. ओके, so happy is anticipation, happy is joy, happy is trust, and happy is positive. Okay, so we're going to run this entire statements that we saw, and we using get NRC sentiment, for that entire thing, and that will take time before it gets on to the and then eventually I'll do a graph of that. So just see. So you will get a bar graph on anger, anticipation, disgust, fear, joy, sadness, surprise, trust, negative and positive. इसके ऊपर एक बार आएगा. I will show you. Okay, fine. Let it take time. But meanwhile, let me see if I can show you an indicative bar graph, right? One second. I'll just how will it look? Just in case it doesn't work, I mean, it'll take time, right? So just in case it is delayed, I'll just show you how will it look. I have a screenshot of that as well. वन सेकंड स्क्रीनशॉट नहीं बट हाँ कॉपी किया था. एक मिनट दे दो मुझे अभी बताता हूँ मैं सो दैट वी डोंट हैव टू वेट टिल द टाइम इट गेट्स डन. So the eventually it will look like this. Where do I go? Stop share. Okay, so yeah, it will look like this. Anticipation, anger, same. Anger, anticipation, disgust, fear, joy, sadness, whatever, and you will have the scores. So whatever the levels of sentiments in the given organization. You'll also say that okay, when positivity is largely driven by trust and maybe anticipation. Okay, sadness is contributing most to the negative. So suppose fear is contributing more, which means that you'll have to do something about fear in the organization. So do some interventions wherein find out why fear is there. First of all, you have focus groups and all that kind of stuff, and then work on it. So that you can do and come up with some intervention. So obviously those things you need to analyze, and this is just thousand ka data, but you can use if you have more number of. So this can be done for a lot of other purposes. You have done text mining as well, so this can be done for a lot of other purposes as well. But in engagement analytics, the scores that you get in response to the questionnaire are important because that is what is used for quantitative analysis. But qualitative analysis comes from when people answer this open-ended questions like what is positive about this organization and what is not so positive of this organization or whatever. Secondly, in questionnaires you ask what you want to ask, but suppose employee may want to say something which is not there in the questionnaire. So where is this place where he or she can express his feelings? That is where the entire thing works, which is what qualitative analysis does, and that's why these scores are important. Okay. So this is a small thing that I wanted to show you. It's almost like 9:52 now. So we stop here because R is still working hard on that. But you understood, right? I mean, this is exactly it will come. This particular graph that I'm showing you is the graph which had actually similar to that the graph had come down. Okay. Chalo. So with that, I think we are concluding. Again, my apologies for today for the delay. And Subrat, you and Sachin, and occasionally, of course, Subramaniam, but you've been there and really, I'm sure I'll miss you. The only four sessions, but I think we interacted a lot. And you asked both of you asked a lot of questions that helped me to explain things much better. So, well, first of all, salute to you. Anybody who is upgrading and reskilling and retooling, you're putting more efforts, guys. Like this is really, really commendable stuff. So hats off and keep growing. Uh, should you ever think that I can be of any help at any point in time, no commercials intended. I believe knowledge is to be shared. So feel free to ping me on my LinkedIn, and if you need any help. Uh, oh, great, great, super. Thank you so much for that. Unfortunately, there's so much to show, and you would have seen that. No? I've created so many applications. There was no much of a time to discuss all those things. So hopefully, uh, yeah. So whenever, if you feel like I can be of help, please feel free to ping me. Yeah, they're real world examples, correct? Because there's no point in just showing the. You know what? I would have shown you the slides after slides after slides. The Google ये करता है, Apple ये करता है. All of those guys do it. General Electric does this and all. But that doesn't mean anything till the time you actually see. I have to show you. I have to open up the engine room and show you how things work, right? So that is something was my objective of the entire stuff because I know which function. And Subrat, by the way, Subrat and Sachin, you are in which function, if I may ask you? Subrat, thank you so much for that. Which function do you belong to? Subrat and Sachin, both of you? You're a petroleum engineer. Oh wow, I love it. I lived petroleum life. Are you upstream, midstream, or downstream? By any upstream exploration, production, no refinery. So, oh, you're in refining, exploration, production. Okay. Are you in ONGC or something? Oil India, Shell, Kane Energy, Kane. Thought so. Chennai. Sachin, you're in automation. You're a developer. Okay, okay. So you do what? Robotic process automation, RPA. Subrat is in Rajasthan. Kane. Okay, okay. Extraction. Okay, got it. ETL. Acceptor. Fantastic, fantastic. Guys, upgrade yourselves, yeah. And of course, Python, and also that's a good thing going. So, Subrat, for your information, so you've been looking for transition into analytics job role. Subrat, I'm sorry, I'll take a couple of more minutes since you've now focused on machine data analysis. Okay, so quickly, let me tell you one very important thing, both of you. Subrat, for you, if you can actually focus on, I worked for Reliance for 5 years. Before that, I was in Arthur Anderson in energy. So worked in Saudi Aramco and all that kind of stuff as a consultant. Since that's how I know quite a bit of oil. So if you can really focus more with machine learning and analytics on supply and trading, okay? So which crude to buy and which product to sell, that there's huge algorithm, and there is huge scope also, which is basically a trader. So if you get into crude trading and crude supply, I think there's a lot of scope there, because it's a fantastic profession. Okay, and Sachin, since you're working on machine learning data analytics, I think consolidate more on reinforcement as well as neural nets. And from there, how can you marry that with a generative AI? Okay, like in fact, I didn't have time, otherwise I've shown you that as well. So you're talking about attrition. What we generally talk about is, uh, you in attrition, you take care of the organizational data, which I have been doing. So just in case you speak about, say, Python or whatever, Java, C sharp, various skills you have. Now, a guy in a deficit, resources surplus country like ours, people will not leave unless until they have a demand. So there's a push and there's a pull. So we are calculating attrition as per the push, but pull कहाँ से आएगा? Now that data you get it from Gen AI. Okay, so how you marry generative AI to the existing reality of the organization, merge it together, and then create various models. That will help a lot. I'm just giving you tinkers so that you can work around that. And Subrat, for sure, right? I mean, there are certain, for example, seasonality hoti hai in the demand of high speed diesel, or maybe motorized motor spirit. So in say winters, the entire north hemisphere gets cooled down, right? So they require more diesel. So, and in the summertime, more motor spirit, because everybody is on the road, so they're spending more time more motor spirit. So this is one seasonality, but there are several seasonalities which you can kind of consider, and then depending upon that, you can decide how much supply of a motor spirit or an HSD or sulfur. There are several things here, and so many oil products are there. Both of you, I'm sure, have great uh, life ahead. So all the very best. Stay in touch, and thank you so much for these 4 sessions. Okay, chalo, take care.